Welcome back to Aurora Tech Channel. Today, I'll be reviewing the AtomStack Hurricane 55W CO2 laser engraver. They have produced a wide range of diode lasers, from the A10 with an affordable 10-watt module to the A70 featuring a powerful 70-watt module. The Hurricane is their first CO2 machine. A fully enclosed machine built with a sturdy sheet metal enclosure. It offers a working area of 500 by 300 millimeters, which can be extended to 800 by 500 millimeters with an optional feeder. The motion system for the X and Y axis uses steel wheels, allowing the machine to achieve a top speed of 600 millimeters per second. The motorized Z-axis includes a probe that automatically detects material thickness and adjusts the focal length, making setup quick and hassle-free. It has a 5-megapixel camera, which moves to the top when the lid is fully open. This design enables the camera to capture the entire working area from a distance without requiring an ultra-wide-angle lens. On the side of the machine, there's a built-in water tank that cools the CO2 laser tube, eliminating the need for external water buckets and aquarium pumps often used with budget CO2 laser machines. When it comes to software, the machine is compatible with Lightburn, but AtomStack also provides their free AtomStack Studio software. In this video, I'll primarily use AtomStack Studio to determine if it can serve as a full replacement for Lightburn. For computer use, you'll need to connect the machine using a USB Type-C cable. When using their phone app, you have the option to connect via Wi-Fi. The Hurricane supports several advanced features, including 3D engraving, batch production, and a red light indicator for precise laser path alignment. For safety features, it includes an emergency stop button, a physical key lock to prevent unauthorized use, and a frame detector that triggers the water tank to function as an automatic fire extinguisher when necessary. For those looking to expand their setup, AtomStack offers a variety of optional accessories, such as a triangular prism bed, conveyor feeder that allows you work directly with a 4x2 panel, the riser base allows the machine to work with much taller materials, and a smoke purifier to manage smoke for indoor use. The retail price for this machine is $2,800, positioning it between a standard CO2 laser machine and a more advanced smart CO2 engraver. I'd like to thank AtomStack for providing this machine to review and for sponsoring today's video. And with that, let's get started. The machine arrives in a large box and is protected by custom laser-cut foam. Everything comes pre-assembled, so no setup is required. The accessories and cables are neatly packed inside. Included are the ducting, user manual, power cord, USB-C cable, various accessories and spare parts, the calibration card, and cardboards for camera calibration. Additionally, there is a fixed focus block and a funnel. By default, the machine is equipped with a standard honeycomb bed, but a triangular prism bed is available as an optional upgrade. Before using the machine, the first step is to fill the water tank. It is located on the right side of the machine with 2 caps on top. Open both caps, use the funnel, and add distilled water until the level is just below the maximum line. For smoke management, you can either use the ducting to vent the smoke outside, or if you've purchased a smoke purifier, connect the machine to it instead. The tool head is equipped with a metal cover that houses several components, including the laser mirrors and nozzle. Additionally, there is an air tube for the air assist pump, a thickness gauge that functions similarly to a BL Touch to measure material thickness, and a motorized Z-axis. The Z-axis can be controlled via the software or by pressing the button on the machine's control panel. For software, you can use Lightburn or the program provided with the machine. The latest version is available for free on the AtomStack website. Once the software is installed and the machine is connected to your computer via USB, it will be detected automatically. The first task is to calibrate the camera. You can use a piece of plywood or the cardboards included with the machine for this process. Start by drawing a preview in the software and engraving the calibration pattern. After engraving, return to the software to check the calibration score. If the score is less than 3, the calibration is successful. Next, I added some text and placed it just below the engraved pattern in the top left corner. For speed and power, I set both parameters to their maximum values. The engraving was very accurate, closely matching the planned position in the software. So, I assume everything is working normally, and we are ready for more tests. One of the features I frequently use in Lightburn is material testing, and it seems this AtomStack software has a similar feature. I will test engraving at speeds ranging from 10,000 to 50,000 millimeters per minute using power levels from 10% to 100%. However, it seems there is no option to select line, fill, or cut mode, so let's see how it works. It turns out the software is testing in fill mode, but 10,000 millimeters per minute at 100% power is too much for this mode. I'll stop the test and adjust the power levels from 10% to 40%, then restart the test. As you can see, even at 10,000 millimeters per minute and 40% power, the engraving is still too dark. At the previous 100% power and the same speed, it actually burnt through the entire sheet. This 55-watt CO2 laser is significantly more powerful than a 40-watt or even 70-watt diode laser. In this case, material testing at high power isn't very meaningful, as the laser can still engrave effectively at 50,000 millimeters per minute with just 10% power. Next, I'll test cutting. I'll start at 100% power with speeds ranging from 1,000 millimeters per minute to 1,500 millimeters per minute. All the squares cut through completely, then I'll increase the speed to 1,600 millimeters per minute and up to 2,000 millimeters per minute. Once again, all the squares cut through without any issues. Since the 15mm squares don't provide much room for acceleration, the difference between cutting at 1,000 millimeters per minute and 2,000 millimeters per minute isn't very noticeable. To test this further, I'll cut a long bar to provide enough space for acceleration and see if the laser can cut through completely at 2,000 millimeters per minute. As expected, this laser is powerful enough to cut through 3mm plywood at 2,000 millimeters per minute with ease. Now, I'll start my first project, engraving a logo and cutting it out. I'll use the preset parameters in the software to see how it performs. For 3mm plywood, the cutting settings are 1,200 millimeters per minute at 80% power. For engraving, when selecting the same 3mm plywood, the software uses 18,000 millimeters per minute at 30% power. These settings align perfectly with our earlier test results. The job took about 13 minutes to complete. It cut through the plywood completely, and the engraving result turned out quite impressive. Next, I'll try engraving a photo on the same piece of plywood. I'll position the photo between the logo cutout and the left edge of the plywood. I'll use the same parameters, 18,000 millimeters per minute at 30% power for engraving, and 1,200 millimeters per minute at 80% power for cutting. This job took about 14 minutes, and the engraving result is not only excellent but also better than any other laser I've tested, including other CO2 lasers and various diode lasers of different power levels. Okay, let's try some batch production. This machine has a camera, but the software doesn't support automatic positioning. I'll arrange these small tags in a straight line and use the software to align and position them manually. For the material type, I'll select the plywood settings. Although the wood tags are thinner than 3 millimeters, about 1.5 millimeters, I'll see if the camera, calibrated for 3 millimeter plywood, still works. The result is not bad. Aside from the first and last tag shifting slightly to the top, the rest are fairly accurate, even though the tags are only 1.5 millimeters thick, while the camera was calibrated for 3 millimeter plywood. Overall, the accuracy is acceptable, and the engraving looks really good. Next, I'll try cutting some thick wood, starting with this 1/2-inch poplar wood. Using a speed of 200 millimeters per minute at 80% power, it cuts through completely. Then I'll try the thickest wood I have, a common 19mm wood board from Home Depot. Using a speed of 100 millimeters per minute at 100% power, it also cuts through cleanly. Even when I flip it over, the bottom remains fairly clean. I will also use the same piece of 19mm wood to try some 3D engraving. The software itself doesn't support 3D grayscale conversion. However, it does include some sample images. I'll select the 3D engraving option and set the material type. Since I'm using the same piece of cheap wood board from Home Depot, I'll select boxwood and let the software set the parameters automatically. The sample file has a dark background, which I don't really like, so I'll run an additional cut operation to cut the circle out. The workpiece cuts through completely. I think the boxwood settings are a bit too dark for this cheap piece of wood, but the result still looks pretty cool. The object has a nice 3D effect, but it's not very noticeable on the screen. Next, I will try some different materials, starting with acrylic. I'll make a ruler on 3mm clear acrylic, a material that a diode laser can't handle, but it's perfect for a CO2 laser. I'll use the software's preset parameters for both engraving and cutting. The marks are clear, the cut is clean, and the quality of engraving and cutting acrylic with a CO2 laser is truly impressive. Then, I will engrave on a slate coaster. Since the camera was calibrated with 3mm plywood, it won't work well on a much thicker material. I tried to offset it manually by placing a piece of paper underneath and drawing 2 circles. After my rough offset adjustment, it was still slightly off, shifting to the top and left. Moreover, using line mode on this slate doesn't look good, so I'll run the same job again, but this time using fill mode. Despite the slight misalignment, engraving on this slate using fill mode still looks pretty nice. Next, I will try engraving and cutting this PU leather. Using a CO2 laser to engrave leather is better than using a diode laser, as it doesn't generate excessive heat or burn the surface. After that, I'll test this black-coated aluminum card. Since the card is thin and black, I'll place it on a 3mm plywood sheet to make camera alignment easier and as accurate as with 3mm plywood. The laser cleanly burns off the coating on the aluminum card, revealing its natural color. Finally, I will test the riser base and the feeder. The riser base has a very simple design, a frame to lift the machine with front and back covers. Once the machine is placed on the riser base, the maximum object height increases from 90mm to about 175mm. The riser base is required if you want to use the feeder, as the feeder sits directly on the base. It's similar to a 3D printer Y carriage, but with a much larger bed. Once this bed is installed, you can place a 2x4 panel from Home Depot directly on it without cutting it into smaller pieces. I will engrave some text and my logo on this 2x4 wood panel. I'll maximize the working area and make the sign 500 by 800mm. For engraving, I'll use the same parameters as for plywood, 18,000mm per minute at 30% power. For cutting, since the panel is about 6mm thick, I'll use 400mm per minute at 90% power. The job took almost 2 hours to finish, and the 6mm plywood was cut through completely. The workpiece is almost as large as the machine, and the result turned out very good. It's incredibly convenient to use a full 2x4 panel. Not only do you avoid cutting it into smaller pieces, but it's also quite affordable. A panel like this from Home Depot costs only around $10, and I can still use the leftover material for smaller jobs. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The overall build quality is solid, it features a sheet metal enclosure, and the machine's weight makes it super sturdy, even when operating at high speeds. 2. The autofocus function is very convenient. It doesn't just work with AtomStack Studio software, the machine also has a hardware button on the control panel. Pressing this button activates the probe on the tool head, which automatically sets the correct focal length. This makes it compatible with Lightburn or any other free software that can operate a laser engraver. 3. The preset parameters included in the software are spot on. Most of the jobs shown in this video use the preset settings, and the results are excellent. 4. In terms of engraving, especially photo engraving, it performs significantly better than most other engravers, including diode, CO2, and even dual laser machines. 5. The camera is mounted at the front of the machine and takes a snapshot when the lid is fully open. This increased distance between the camera and the working area means a super wide-angle camera isn't needed to cover the entire bed. Using AtomStack Studio, the alignment process is much easier compared to Lightburn, and the accuracy is better than the average webcam used with Lightburn. Now for the cons. 1. The machine has a solid build, however the accessories have room for improvement. For example, the riser base lacks dividers or adjustable layers to position the tray and cutting panel at different heights. If your workpiece is too tall for the standard setup, but too short for the riser base, you'll need to place something underneath to raise it to a workable level with the machine. 2. Another odd issue with the riser base is that you can't use the tray. In this situation, the safety limit switch prevents the machine from operating. To work around this, you have to tape the limit switch to allow the machine to function normally. This could be easily resolved by adding an option in the software to disable the limit switch when the riser base is enabled, rather than relying on a DIY solution like taping it. 3. The so-called conveyor feeder shouldn't really be called a conveyor feeder. I would expect a conveyor feeder to handle much longer materials and offer a significantly larger working area, at least 6 feet or more. A more accurate term for this accessory would be a bed extension, as its maximum working area is only 500 by 800 millimeters. This is much smaller than I expected compared to other feeders available on the market. 4. The AtomStack Studio is a simplified version of Lightburn, and you can likely use it for 80 to 90% of your tasks without needing to spend extra money on Lightburn. However, the software lacks refinement. For example, the material testing feature only supports fill mode, the operation order cannot be rearranged, and preset material names are too long to display properly in the interface. You have to hover over them to see a file name style description. Additionally, the 3D engraving and batch production features don't perform as well as in other software like Xtool Creative Space. While these issues don't impact the core functionality of the software, I would like to see more refinement to improve the user experience for end users. Overall, the AtomStack Hurricane 55W CO2 is a solidly built machine. I have no complaints about the machine itself. It delivers the best results I've ever tested, especially in engraving. However, the accessories and software have room for improvement. Accessories like the riser base and the so-called conveyor feeder could have been designed better to allow users to get more functionality out of them. The software is fully functional, but lacks refinement. As for the machine itself, it performs exceptionally well, provided the 500 by 300 millimeter working area meets your needs. If it does, this machine is an excellent choice. If you're interested in the AtomStack Hurricane 55W CO2 laser machine, you'll find the link in the description below. Don't forget to also check out my website, auroratechchannel.com, for the latest recommendations for 3D printers, laser engravers, and CNC machines. My price tracker also scans popular brand websites and updates prices hourly to help you find great deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.